Hello everyone. I would like to introduce myself. This is Dr. Anand Shankar Raja. I work as an assistant professor with the Department of Commerce, Christ University, Bangalore. In today's video lecture, I would be explaining about one of the most important concepts, which is decision tree prediction, and also using one of the most important node, which is called the ROC curve. For this, I have taken the example of German credit details and the target customers. Let me give you a scenario and then let me move to the practical application using the KNIME platform. For example, when a bank receives a loan application, based on the applicant's profile, the bank has to make a decision regarding whether to go ahead with the loan approval or not to give the loan approval. There are two types of risk which is associated with the bank's decision. In case if the applicant is extremely good, if his profile is good, but unfortunately if the loan is not given to the candidate, which means if the loan is not approved, then the bank is losing one of the most prompt customers. It results in a loss in business for the bank. If the applicant is a bad credit risk, and if he doesn't have the capacity to repay the loan, but still, if the bank provides the loan to that person, then the bank will never get back the loan. So it is assumed that both different types of risk has to be taken into consideration. So for this purpose, it is very important to analyze the demographic constructs of the customers, which might include the basic demographic factors such as age, marital status, income level, educational qualification, area of residence, how many members are there in the family, and of course the socio-economic details as well. And apart from that, it is always important to trace information pertaining to the background. What business do they have? What is the earning capacity? Where do they have their bank account? What type of bank account do they have? What type of investment they have? How do they make use of the credit? And how will this loan money be used? What is the assets? What is the liabilities? So there are different areas which has to be introspected by the bank management. So this video lecture would address the problems pertaining to the decision trees, the type of data which has to be used, the process which has to be taken into consideration to successfully perform the decision trees and to predict based on the demographic constructs and the socioeconomic constructs, and also to measure the accuracy of the model and the reliability of the data. So it is going to be a holistic package. So to facilitate this, I'm going to use KNIME platform, which is an open source analytical platform which we can depend and we can perform the decision trees. So the data is very freely available in different databases like Kaggle. You can go to Kaggle and you can please do type German credit data and you get the data. The data sheet might be in .csv format. It might also be in Excel format. Whichever is applicable, you can download the same and then you can start performing the decision tree analysis. In this process, we'll be using some important nodes. The first node is the file ready. The second one is to use a column filter to take only those data elements which are needed and to avoid few data elements which are not needed to proceed further. Later, we will be dealing with one of the most important node, which is called the partitioning. The data has to be split into training data and test data, which follows the mechanism or the ratio level of 80-20%. 80% of training data and 20% of test data. Then we'll be using the decision tree learner and the decision tree predictor. We also have to check the accuracy of this predictive model using the scorer node, where we will be checking the accuracy statistics and the coherence kappa. And of course, we have to use the ROC curve. The ROC curve will tell how far the model is able to split the data into two different extremes. So now let me take you through the KNIME platform and show you practically how to perform a decision tree using the German credit data, and also to use the ROC curve and to write the inference for the same. So this is the KNIME platform, which you can see. It is firstly very important to open a new project. So I go to the file menu and I click new. So this select a wizard box would appear. You can see these two options, new KNIME workflow and new KNIME workflow group. I'm going to choose new KNIME workflow. I'm clicking next. You can give a name for your project. I'm going to give a new name, which is called ROC curve. Okay, ROC curve and decision tree. You can give any name as per your comfort, and then you can click finish. So now the project has been created. So now let us look into the question which we have, right? So this is a question. There are 8 important steps which we have to follow. The first step is to import the data file using an appropriate node. Let us introspect on this step. Any type of data sheet will be imported into the KNIME platform using the file reader node. In case if your data sheet is complicated, if it has a cluster of different varieties of data, like numeric data, categorical data, then other types of scaling option, too many missing values, then probably you can use a file reader complex format. But in this case, we will just be using a file reader. In case if your data sheet has been saved in MS Excel format, then you can use the Excel reader node. Or you can try to convert your Excel sheet into a .csv format, and then you can import the data into your workflow. The choice is left up to you. The second step, we'll be using the filter node to filter only specific rows which has a missing value. Why should we use this node to filter only a specific value? It doesn't mean that you have to consider all the data elements for further process, right? You can choose those data elements which are needed. And you can also avoid few data which is not needed. Say, for example, probably I might not consider number of members in family. Or probably I might not consider gender. The other demographic factors and socio-economic factors I might consider. So you can use a filter node, that is a column filter node, and you can locate which data elements you have to further take into the analysis. So that is with regard to step. Now let's get into step 3. Convert number to string. I have mentioned very clearly in my previous video lectures where decision tree will understand only the string variable, especially when it comes to a binary classification prediction. So it is important to use convert number to string. Step 4 is to use a color manager node where we can bifurcate the data using different color patterns. You and me will very easily understand the binary classification. But for a new person who's looking into the data sheet, they might find it very complicated. So to make things very easy, to provide a very easy visual representation, we can classify the data using a color manager. And apparently when you use the decision tree, we have two different extremes. 0, which is negative, and 1, which is positive. Target consumers who will give back the loan and target consumers who will not give back the loan. So for easy understanding and for visualization purpose, we have to use the color manager. So that is why the fourth step deals with using color manager node for the target binary classification in this data set. Fifth one is to split the data into learning data and test data. Before proceeding with any decision tree model, the data has to be classified based on 80-20%. So that is why we use a partitioning node to partition the data into two different data sets. So after we perform step 5, we perform the decision tree analysis where we use the decision tree learner and the decision tree predictor. It is very important to check the accuracy and reliability of this predictive model. So for that per se, we will be using a scorer node, which we will be taking it from the node repository. Eighth one is a little interesting to check how far the model has the capacity to classify the customers into positive customers or negative customers or good customers or bad customers or valuable customers for the bank and invaluable customers for the bank. So for this, we have to depend on the ROC curve, which I would be explaining to you in detail when I do the analysis. You can also see a conclusion. Assume yourself to be a bank manager and conclude this by analyzing and interpreting on the following items: data accuracy, reliability of the data, and points of predictions being used, right? So this is the question which we have to address. And now we would be starting with the KNIME analysis. So before proceeding with the KNIME platform, let me first explain about the data sheet which we are going to use for this analysis. I've told you before that this is a freely taken data sheet which is available in most of the databases. Kaggle has this data set which you can download. So I have downloaded in Excel format, but I've converted the same into a .csv format. So as soon as you download any data sheet, the first important thing which you have to do is to check how many rows are there and how many column elements are there. And apparently I can see there are 500 rows and 20 column items. Now let us see what are all the different column items. We have personal status, duration, status of the credit, purpose, credit amount, savings, marital status, how many members are there in family, family personal details, other debt details, residence details, property, age, nature of accommodation, family members, qualification, number of credits which has been availed or provided, telephone, are you belonging to German or do you belong to any foreign country, and the target. So this is a classification, binary one. So it has been classified into 0 and 1. I've told you before, 0 means it is people who will not be suitable. That is invaluable consumers or customers for the bank. And 1 means the valuable customers for the bank. So if we have to write an inference for this data set or this data sheet, we have to write that the German credit data set has 500 rows and it has 20 column items. You can also write if it has any missing values, the nature of data, how many categorical data you can observe, right? And you can also talk about if any missing values are. So it is very important for a data scientist to first explain all these items. Now let us proceed with the KNIME platform. So welcome back again to the KNIME platform. So this is the project which I have created. So let us start working with the German data. First and foremost, we have to use a file reader node, which you can take it from your node repository. So I go to my node repository and I type file reader. I use the drag and drop option and I place it into my workstation. I double click the same and I give a name for that as German data. In brackets, if you want, you can also mention loan data. Any name you can give as per your comforts. So now we have to import the data, and for that, I'm going to right click, configure. So when I press configure, the configuration window will open. You can see one menu here which is called browse. I click browse. I go to the folder where I can locate my data. I take my data, I click apply and I click OK. You can see that there is a change in the signal color which is moved from red to yellow, which means it is ready to be executed. So now how do we execute this? Right click and execute. So you can see that the signal is in green color. Very successfully it has been executed. Now let us check the output. Right click and go to the very last option, that is a file table, and you can see the data. You can also observe that there are 500 rows here and 20 column elements. You can also see one missing value, which is represented with a red color question mark. If you want, you can retain this row, or if you feel that this should not be taken further, you can remove it using the row filter node. I'm going to consider this. I'm not going to remove this row. I'm going to retain this. So now let me close this. So the second important one which we have to use here is the column filter. So go to your node repository and type column filter. You get to see this node. Use the drag and drop menu and please drag it into your workstation. Please connect your file reader with your column filter node. Give a new name. I'm just going to give this name as column filter. I'm going to right click and configure. So when I configure, you can see the column filter configuration window, which has two boxes. One is the inclusion box in green color. The second one is the exclusion box with red color. As the default option, you can see all the data into the inclusion box. I've told you before, it is not compulsory that you have to consider all these elements for further analysis. You can decide, you can see, my assumptions are totally different from yours. Your thinking, your assumptions are totally different from the other person. So probably I would say purpose is not needed. Being married for how many years is not needed. Probably personal details with gender is also not needed. But other details are very much important for me. But this perspective would be totally different from yours. So I'm clicking apply, I click OK, and it is ready to be executed because it is in yellow color. Now I right click and execute. Now it has been executed. Now let us check the output. I right click and go to the filter table. In the filter table, you can see that initially it was 20 column items, but I've removed 3. So you can see only 17 column items. So only based on these 17 column items, I'm going to perform the decision tree analysis. So this is step number. Now let me close this window. So step 3, which we discussed earlier, is to convert number to string. I'll tell you why number to string has to be used. Before that, let me take this node, go to your node repository and type number to string. And apparently you can see number to string now. So use the drag and drop option and please pull it into your workstation and give a name for that. That is number to string. And now you can connect your column filter to number to string. Let me first tell you why we are going to use this. If you look into this data sheet, S means it is string, and I means it is an integer. We have to depend on this target. Our target customers for the bank. Valuable customers and invaluable customers, right? So they are grouped under this name which is called target. So target is our ultimate goal. That is our ultimate aim for this decision tree. And apparently you can see that it is represented by I, which is an integer. So you cannot proceed further with the decision tree before converting an integer into a string. So this has to be converted to a string for me to perform further. So I close this. Let me configure my number to string. I right click. As a default option, you can see all the elements are into the inclusion box, right? Whatever has been expressed in form of numbers. But again, I've told you before that we should concentrate only on this variable, which is called target. So I take everything into my exclusion box and I take only target into my inclusion box. I click apply, I click OK, and I execute. So now let's check the output. Right click and transformed output. You can see that target is denoted with S, which means it has been converted from an integer to string. So it is ready for the further analysis. So now let me close this window and let me proceed with the next. So before partitioning the data into two different extremes, we have to use a color manager. So go to your node repository and type color manager, and you can see this node, which is like a water drop, which has a color combo of white and black. So drag and drop it into your workstation and give a name for that. Probably I would give a name like visual representation. You can give any name according to your choice. So now let us configure, right click and configure. Our target column item should be target only, right? Because that is what we are going to predict. And look at this. 0 means it is people who will be invaluable consumers, and 1 means who will be valuable consumers. Sorry to say that there is a stereotypical mentality that green means it's a positive color and red means it's a negative color. So I'm going to change 0 with red and green for 1, which means people who are invaluable customers for the bank are represented by 0 and the color pattern is red. People who are valuable customers for the bank are represented by 1 and the color pattern for them is green. It's not compulsory that you have to use such type of colors, but it depends on your personal choice. You can use any colors for 0 and 1, the binary classification. So I click apply and I click OK. And now I execute. You can also keep arranging your workflow, because workflow means it should be a process. It should be a very neat process, right? Okay, now we will be using a very important node which is called partitioning node. I go to the node repository and I type partitioning. So I get to see this node. I use the drag and drop option and I place it into my workstation. So I'm going to give a name for that. That is learning data and test data, right? I've told you before that learning data should be 80% and test data should be 20%. So now let us connect our color manager to the partitioning. Now let us configure, right click and configure. The default menu is 70-30 bifurcation, but following the Pareto rule, which is 80-20, we'll also follow 80-20. So 80% of the data is training data and 20% of the data is test data. You can use this stratified sampling and you can select target as your variable. You can click apply and you can click OK and then you can execute. So once after you execute, you have to know how far the data has been split into two different categories. So right click, you can see first partitioning and second partitioning. Let's see the first partition. You can see that 500 data set has been first classified into 400. So 400 rows for the first data set. And for the second partitioning, it is 100. So 400 as a sample for training and remaining 100 as a sample for testing. Now, let us use the decision trees. So go to your node repository and try decision. When you type decision tree, you can get to see decision tree view, decision tree learner, decision tree to image, decision tree predictor, and decision tree rule set. We have to take the decision tree learner, and we also have to take the decision tree predictor, right? Learner and predictor would always go hands on hand. So I'm going to place my learner node and my predictor node. I'm going to connect my partitioning node to my learner and my partitioning to my predictor. And I'm also going to connect my learner with my partitioning. I'm going to give a name for the learner node. I'm also going to give a name as predicting node, right? Okay, now let us configure this. Right click and configure. So this is very important. Class column is target. Quality measure is Gini index. No chroning. Number of records per node. If you want, you can have it 2, but if you have 6, the number of iterations would be good. Number records to store for view is 10,000. Number thread is again 8. And probably we also have to go for the binary nominal split. And root split column, you don't have to force root split column with a specific variable like property, age, or nature of living, or family members, or job. Let the decision tree take any type of variables from the demographic construct and let it do the rotation, right? So click apply and click OK, and please execute. Now let us configure the decision tree predictor as well. So you can see that there are two options. Maximum number of stored patterns for, let it be 10,000. And below that, you can see change prediction column name. So you can activate that, and also you can ensure that you activate append columns with normalized class distribution. So click apply and click OK. And please do execute. So now let us check our decision tree. Right click your decision tree learner. And you can see this, which is called view decision tree view sim. So this is just a very normal classification of your decision tree, which is showing how many data has been taken. But if you want a holistic picture, you can see view decision tree. So now this is the decision tree which you can see. So you can expand your decision trees. You can keep expanding your decision trees into different branches, and it's a wonderful decision tree. So this is why we have to use a color pattern to bifurcate the data. So valuable customers and invaluable customers, right? So you can see that the entire decision tree is giving you a holistic picture. So you can see valuable customers and invaluable customers represented in form of red and green, right? And each for everything. For status, you have for the credit amount below and above a threshold limit, right? So, and duration in months. I think we can take a lot of decisions from these decision trees itself. So now I've closed the decision trees. it is important to check the accuracy and reliability. So I'm going to use the scorer node. I'm going to my node repository and I'm going to type scorer, and apparently I take my scorer node into my workstation. I connect my decision tree predictor to scorer. I also take ROC curve into my workstation, and I am going to connect my ROC curve to my decision tree predictor as well. So now let us perform the scorer node and the ROC node. But before that, let us understand why a scorer node should be used and why a ROC node should be used. So when we use the scorer node, we will first observe about the confusion matrix. A confusion matrix is a very popular measure which has been used while we solve any classification problem. So this confusion matrix is usually applied for all the binary classification as well as for all the multi-class classification problems. So there are four outcomes of a confusion matrix, that is true positive, true negative, false positive, and false negative. What do you mean by true positive? So these are the cases in which we predicted, yes, they are valuable consumers. They have the capacity to repay the loan. And in reality, yes, they have the capacity to repay the loan. The second one, what is true negative? We predicted certain cluster of people as invaluable customers, that they will not repay the loan. So in reality, they don't have that capacity to repay the loan. So that is why it is true negative. Now, what is false positive? We predicted yes, but in reality, it is the vice versa. The same is applicable even for false negative. We predicted no, that is invaluable customers, but in reality, they are valuable customers. So it is very important to determine the confusion matrix using true positive, true negative, false positive, and false negative. The second one, which we have to observe in the scorer node, is the Cohen's kappa value. So the Cohen's kappa value is essentially a measure to how well the classifier performed as compared to how it would have performed simply by chance. In other words, a model will have a high Cohen's kappa score if there is a big difference between accuracy and the null error rate. We also have to give importance to the ROC curve. ROC curve is known as the receiver operating characteristics curve. It is a graphical representation which shows the performance of a classification model at all classification threshold. So this curve usually has two parameters, that is true positive rate and false positive rate. In any machine learning, performance measurement is an essential task. So when it comes to a classification problem, we have to rely on the ROC curve. So when we need to check or visualize the performance of a multi-class classification problem, we also use the AUC, that is area under the curve. ROC also we use, which is receiver operating characteristics. So it is one of the most important measurement metrics for checking if any classification model has performed well. How to speculate about the performance of the model? So that is where we have to interpret based on the ROC. An excellent model which has an AUC. What is AUC? Area under the curve. If it is near to 1, it means that the model has a good measure of separatability. The data has been classified extremely. Valuable customers and invaluable customers. In case a poor model has AUC near to 0, which means it has the worst measure of separatability. Both will be close to each other, right? They might also fall on the street. So this is how we have to predict the ROC curve. So I hope we are clear with the very basic accuracy and the performance metrics of a classification model. Now let us check the same using the KNIME platform. Now we are back to our KNIME platform. Let us first configure the scorer node, right click and configure. So when we configure the scorer node, it will ask us first class and first column and second column. The first column should always be target and the second column should always be prediction target. So click apply and just click OK and execute. So right click, you can see the confusion matrix, which I explained. So we have the outcome of the confusion matrix. We also can see the accuracy statistics. You can see the overall accuracy, which is 0.92, and Cohen's kappa is 0.775. Accuracy is somewhere close to 0.9, which is comparatively good. Accuracy more than 0.7, which means the model has a very good accuracy. Cohen's kappa is close to 0.7, which is again a very good measure. So when you write the inference, you have to write C and Cohen's kappa for this model, which is pertaining to the German loan details, is perfect. It is good. So now let us configure the ROC curve. Right click the ROC curve and configure. You can see by default all the elements into the inclusion box. Exclusion box doesn't have anything, so please move all the data elements into the exclusion box. The class column at the top should be only target. And inside the inclusion box, you should have that binary classification, that is P, that is target is equal to 0, and again P target is equal to 1. Click apply and click OK, and please execute the ROC. So please right click and check the interactive view for the ROC curve. It will take few minutes, probably 1 to 2 minutes for the curve to load, and you can see the ROC curve, right? So there are two different extremes here. One is the valuable customers and the other one is invaluable customers. And you can see this. The blue color line touches almost 1, and the orange color line, which almost touches, again 1 in the x-axis. So both in x-axis and y-axis, which shows about the true positive rate and the false positive rate, which means the model is in a position to classify into two well extremes, right? And this is how we have to understand this model. So the ROC curve also is a very good gesture to tell that the model has classified very perfectly. So in this video demonstration, you learned about a problem pertaining to the loan data. We performed a decision tree where we used few important nodes like the file reader, column filter, number to string, color manager, partitioning, learner node, predicting node, scorer, and also the ROC curve. You can practice the same using other different data sheet, and you can write inference for the same. So let me meet you with another video lecture very soon. So thank you so much. Let me remind.